Hey guys and gals, we are going to go over properties of linear functions. This is going to be the last video for a review of prior content before we actually get into Math 2 content. And in this video, we're going to be talking about different attributes of a line, things like x-intercepts, y-intercept, whether it's increasing or decreasing, domain, range, things along that nature. Objective, I can create the equation of a line. Now, that's the underlying theme of all this, is to be able to create the equation of a line given these different attributes. So make sure you're taking good notes. Remember, on the right-hand side, title, essential question. I'm going to let you guys do that this time. With that said, let's go ahead and get started. So here is my first example. A line segment has two endpoints. One of them is -4 and 3, and the other one is 2, 0. What is the slope of the line segments? Write the line segments equation in point-slope form and write the equation in slope-intercept form. So again, I've told you in the past, when you take tests, you will be allowed to use your notes, but you will have a time component to this, which means you can't take all day to do it. So you have to know the content well enough that you're not just going to be staring off at your notes trying to figure things out. You need to know how to use the resources of your notes, and this is a great example of that, okay? So with that said, let's go ahead and take a look at this. What I'm going to do first is I'm going to plot these 2 points just so we can get an idea of maybe what this line looks like. Now, our first point was -4, 3, and our second point was 2, 0. So let's go ahead and plot this guy. Again, graph paper is so important. All right, so -4, 3 is back 4 and up 3, and 2, 0 is right 2 and up 0. So we have these 2 points. Now our goal is to figure out the slope of that line segment. Because we have a graph, we actually have 2 different ways of doing this. We have the graphical approach and we have the analytical approach. If I'm just going to look at the graph, what is the slope from one point to the next? Well, we can see that we went down 1, 2, 3, and we went over 1, 2, 3, 4, 5, 6. So we can conclude that the slope is -3 over 6, or that reduces to -1/2. And so that's our answer for part A. But I want to do that in an analytical approach, which means I want to use equations to do that. So you remember that the slope of a line is y2 minus y1 over x2 minus x1, okay? And so we're going to plug in our coordinates. If you remember in a coordinate, this is x and y, and I called this point 1 because it's the first point that I listed, and I called that point 2. But you could easily go back and forth. You call that point 2 and point 1. The only reason I do that is when I go to plug in the y2 and the x2, I know I'm getting them from the same point. When I plug in the y1 and the x1, I'm getting them from the same point. So with that said, let's go ahead and plug in. We end up with y2 is 0 minus y1, which is 3, over x2, which is 2, minus x1, which is -4. And then simplifying that, you can see that 0 minus 3 is -3, and 2 minus -4, well, that's 2 plus 4, which is 6. So we can see that our slope is -1/2, and that is our answer for part A. Okay? For part B, it says write the line segment's equation in point-slope form. Remember that point-slope form from the last lesson is y minus k equals m times x minus h. And you also remember that the slope is m, so it's -1/2, and then the h and the k represent a point. Now, it doesn't matter what point we use. We're going to use, I'll show you both ways here. We're going to use this point to start with. So we're going to use -4 and 3. So when we go to plug this in, this is going to say y, and then minus, plugging in k is the y value because it's next to the y, minus 3. equals the slope, which is negative 1/2 times x minus, and the h value is negative 4. And then simplifying this just a little bit, we get y minus 3 equals negative 1/2 times x plus 4. And so if you remember from the other day, all you do with the point is change the signs when you're plugging it in. Since that says plus 3, that'll say minus 3. Since that says negative 4, that'll say plus 4. And so this is one version of the point slope form, but that is because I used this point here. If I use this point, the point slope form is going to look a little bit different, but it's still going to mean the same thing. So here's what I mean by that. The other version would be y, and then the y value here is 0, so we could say minus 0 equals negative 1/2 times x, because that's a positive 2, we're going to change the sign to minus 2. And so that's another version of point slope form based on this point. Now you might go, well, those look different to me. That has different numbers, and you're right, but notice they do have the same slope. What I think you're going to see is in part C, when we want to convert those into slope-intercept form, you're going to see that they're the same thing, actually. So for part C, we're going to go ahead and convert those. So I'll use the first one, y minus 3 equals negative 1/2 times x plus 4. We'll go ahead and distribute first. And when we distribute, we end up with y minus 3 equals negative 1/2 x, and then negative 1/2 times 4 is negative 2, all right? So then from here, we want to get y by itself, so we're going to add 3 to both sides, and you end up with y equals negative 1/2 x plus 1. And so there's our slope-intercept form of our line that passes through, or line segment that passes through those 2 points. Let's go ahead and do that with the other equation. Y minus 0 equals negative 1/2 times x minus 2, and see what we get. Well, again, we're going to distribute. So we end up with y minus 0 equals negative 1/2 x, and then negative 1/2 times negative 2 is plus 1. If you're having a hard time with that, I'll go ahead and do it off to the side here. To multiply the fractions, remember you're going to say negative 1/2 times negative 2, but you're going to put that over 1. And then multiplying fractions, you multiply straight across, so you end up with negative 1 times negative 2 is positive 2, and then 2 times 1 is 2, and that simplifies to 1. And so we see the 1 there. From here, normally we would add or subtract whatever this is, but y minus 0, I mean, if you want, you could add 0 to both sides, but you don't need to. You can just get rid of it. What's y minus 0? Well, y minus 0 is y, and then the other side stays the same. And so you can see that no matter what point I used, whether I used the 2, 0 or the negative 4, 3, I did get 2 different looking equations, but when I put them in slope-intercept form, they ended up being the same thing, y equals negative 1/2 x plus 1. So that is my example for you. What I want you to do now is the same thing. Remember, on the left-hand side, because it's a practice, I want you to do the same thing with each of these 2 problems. So in number 1, we have 2 points, 1, negative 5, and 4, 1. That's one separate problem, and then this is another problem. You're doing all 3 of these things on both of these problems. So go ahead and pause the video, do what you can, and then come back and watch me to make sure you're right. Okay, for number 1, we have the point 1, negative 5 and 4, 1. We're going to plug that into our slope formula for A. So we're going to say m equals, remember y2, so it's going to be 1 minus negative 5 for our y1 over our x2 is 4, so 4 minus, and our x1 is 1. And so our slope, 1 minus negative 5 turns into 1 plus 5, which is 6. And 4 minus 1 is 3, and that will reduce to 2 or 2 over 1, depending on how you look at it. So that's my slope. For B, it says write the line segment's equation in point slope form. You can use either point that you want. I'm not going to do both. Well, I'll do both just so you can see the answers. But when it says put it in point slope form, you can pick any point you want. You can pick either point. So this would be y. The y value for the first point is -5. So this will say +5 equals, the slope is 2, times x. The x value is +1. So I'm going to put -1 here. So that is one version of it. The other version would be y. And then that's +1. So I'm going to put -1. Equals, the slope is still 2, and then times x, and since that's a +4, I'm going to put -4 here. And so either one of those works. You didn't have to have both of them, but either one of them work. For part C, it says to write the equation in slope-intercept form. So I'm going to rewrite my first equation that I have here, and I'm going to convert that to slope-intercept form. So again, the first step is to distribute. So we end up with y + 5 equals 2x - 2. And then we're going to go ahead and subtract 5 from both sides in order to get y by itself. So we end up with y equals 2x - 7. And that is your final answer there. Okay? We can do the same thing on the other one. If I distribute, I get y - 1 equals 2x - 8. And then I'll add 1 to both sides. So I end up with y equals 2x - 7. Same answer. But you didn't have to do it twice, just once. So that's number 1. Okay, number 2, again, hopefully you did this before I'm getting into it. We've got -3, -2, and 5, -8. So for part A, we're going to find the slope. So m equals -8 minus -2 all over 5 minus -3. I know that I'm going kind of fast. If you need more help with that, go back and watch a previous video on how to find slope using the formula. So -8 minus -2 is -8 plus 2, which is -6. 5 minus -3 is 5 plus 3, which is 8. And then that simplifies. The common factor there is 2. So if I divide the top by 2, I get -3. And if I divide the bottom by 2, I get 4. So that is my slope on part A. For part B, it says write the equation in point slope form. So we can pick either point. I'll pick the first one. So it's going to be y. That says -2, so I'm going to put +2, equals the slope, which is -3/4, times x, that says -3, so I'm going to put +3. Again, this is an x, this is a y. So you're going to put the one that goes with the x next to the x. You're going to put the one that goes with the y next to the y. Okay, so that's one way of doing it. Another way of doing it, if you did it the other way, it should just be y + 8 equals -3/4 times x - 5. So either one of those works. And for C, when I convert that to slope-intercept form, we have to distribute first. And now here's where it gets a little bit ugly because I'm distributing fractions here. So we'll do this one a little bit slower. We end up with y, we end up with y + 2. And then on this side, when I distribute that, I end up with -3/4x. That one's easy. But what is -3/4 times 3? Well, let me do that off to the side here. -3/4 times 3. And I'm not suggesting that you showed this work in your notes per se. If you want to put it off to the side, that's fine, or on your scratch paper, that's fine. But I'm just showing it to you here because it's a notepad that I have available. Remember, it's 3/1. So when I multiply straight across, so that becomes -9/4. There should be a positive one there. And -9/4 can't reduce, so we have to leave it as a fraction. So that's going to be -9/4. From here, we need to subtract 2 from both sides. Now, going back to reviews, this becomes y equals -3/4x. And then the -9/4 and the -2, how do I put those together? How do I add or subtract fractions? Well, let me put that off to the side here. Remember, when you're adding or subtracting fractions, you put them next to each other. So it's -9/4 minus 2, and we'll put 2/1. In order to add or subtract fractions, we need to get a common denominator. Well, what is a common denominator? Since that's 4, we say, can we make that a 4? And yes, we can. What would we have to do? We multiply by 4 there. Because we multiply by 4 on the bottom, we got to do the same thing on the top. And so you're left with -9/4 minus 8/4. And then remember, when we add or subtract, we just do the tops, we leave the denominator. So that'd be negative 17 over 4. And so that's what we're going to get on part C. That was a little bit more of a problem. And the reason I did that is because you probably noticed if you plotted these 2 points and you graph the line, you probably noticed that these don't actually go through a nice clean whole number y-intercept like number 1 did up here. Okay, so that is your 2 practice problems. Let's go ahead and talk about something a little bit more now. Talking about domain and range. You're putting that back on the right-hand side of your notebook, domain and range. You should be semi-familiar with the ideas of domain and range. Domain and range are basically a box that you can put around a graph, okay, around a line or whatever the graph looks like. And so we'll talk about that here. The domain is the set of x values for that box, essentially. Okay, so it's the set of x values that the function contains, and its boundaries, they're the boundaries of the function in the horizontal direction, side to side. So where do I start? I start here, and I end here, okay? So which way did I go? I started here, that's the x direction, that's the domain. The range is the set of y values that the function contains, okay? So that means we're starting on the bottom and moving our way up to the top. So we're trying to make a box. These lines are represented by x values, and these lines are represented by y values, right? Anyways, so that is the boundary of a function in the vertical direction, vertical meaning up and down, okay? So let's go ahead and take a look at an example. Come on. There we go. Take a look at an example of this. It says, identify the domain and the range of the graph below. Now, this looks kind of gross, to be honest with you. What is this? What's going on here? Well, we're trying to put a box around this graph. And so what I'm going to do is I'm going to put a dotted line at the farthest point to the left. So we can see that if wherever I'm at on this graph, I'm gonna go this way. I'm gonna go to the left until I have no more graph left. You see that I got this blue curve here. I can only go to this point. So I'm gonna draw a dotted line. That's not the best dotted line, or it's not the right spot. I'm gonna take that dotted line and I'm gonna move it over to the end, come on, to the end of the graph. So there's my dotted line. Then I'm going to draw another dotted line on the other side. So all the way over here where the graph ends. So we're going to draw another dotted line on this side. And we'll move it to the right spot there. So that represents our domain. Okay? So for this example, we would say that this domain, and I know this is kind of hard to see, but this domain, if we go back, oh, it stops at -6. So we're going to write it as -6 is less than or equal to x is less than or equal to, well, how far over do I have to go? If I start at -6 and I keep going right, where do I have to stop? I have to stop at this line. Well, what line is that? That's +6. And so that is a way to write the domain, okay? This, by the way, let me write a note for this. This is called inequality form. Inequality form, okay? Another way to write it, it's simpler to write, but it's not as clear as what it means. All you have to do is put -6, 6, and put brackets around it, okay? Either one of those ways works. This is called interval form, okay? Interval form. So we have inequality form and interval form. You can see that the same numbers, -6, 6, and 6. Just depending on what the teacher asks for, they could ask you to put in a specific form. So this is, oops, I forgot to write this. This is the domain, okay? For the range, we're going to do the same thing, but instead of drawing lines this way, we're going to draw lines this way. And so what we need to do, let me change the color of my line so we can see it a little bit better. What we need to do is go to the lowest point on the graph. So low, drop until we get to the end. Oh, that's the lowest point right there. So I'm going to draw a horizontal line at the lowest point. And I actually put that in a good spot. Then I'm going to go from that lowest point, and I'm going to go up, 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 until I get to the highest point on the graph. You can see that the highest point is right there. So then I will draw another line at the highest point, okay? And so we would say that the range starts at, what are we starting at down here? Because range is the y values. We're starting at -3. So we'd say -3. And how far up do we go? We'll go up, 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 all the way up to 6. Now, I do want to point this out because this is kind of important. Notice how this said x. Well, remember, domain is x values. Domain is x values. The range is y values. So therefore, this should say y. And we'll put less than or equal to, less than or equal to. And we'll talk more about why there's a equal sign there later on in future lessons. If I was going to put it in interval form, it would say -3, 6, and those would be in brackets. So those are 2 ways to write the range. Either way works. I accept either way as long as I'm not specific, right? If I just say, what's the domain? You can put it in either one of these. What's the range? Either one of these. But if I say, what's the domain in interval form? You put that. If I say, what's the range in inequality form? Then you put that. Okay, so that's a good example of domain and range. Now here's your opportunity to practice this. So you're going to do the same thing, identify the domain and the range of these functions here. Looks like I got a few more things for you to do on this. It also says determine the slopes and state whether the function is increasing or decreasing. Okay, so let's see here. So let me get my notebook lined up. So go ahead and pause the video, see what you can come up with, and then come back and push play when you think you have an answer. All right, so for number 1, we need to determine the domain and the range. Whoops. Okay, so what I need to do is I need to draw my vertical lines and my horizontal lines. I'm going to draw a box around it. So I go all the way to the left, and I draw a box, okay, or draw a line. I'm going to do the same thing on the other side, draw a line all the way to the right, and then I'm going to do the same thing. I'll just use a different color so it's easier to see. Oops. Give me a second. Okay, on the top. So what's the highest point? The highest point's up here, and the lowest point is there. So we've drawn a box around our picture. And so we would say for number 1, the domain is going to be from, remember, from left to right. So it's going to be, it looks like -5. -5 is less than or equal to x is less than or equal to, and then going all the way to the right, 1, 2, 3, 4, 5, 6 it looks like. So that's our domain. If you put it in interval form, it would look like this, -5 to 6. Okay. For our range, we would say, what's the lowest point? Well, the lowest point is, well, we got to go up 2 to get to the lowest point, so that'd be 2. Less than or equal to y, less than or equal to, what's the highest point? Well, that'd be 2, 3, 4, 5, 6, 7. And in interval form, that would be 2, 7 in brackets. So there's our domain and range. That answers the first question. And then it says determine the slopes and state whether the functions are increasing or decreasing. Well, the slopes are easy enough. We have 2 endpoints, and we can just count. What's our rise and our run? Well, from here to here, we go down 1, 2, 3, 4, 5. So we would say the slope is -5 because we went down. And then to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Can that be reduced? No, it can't. So that is our final slope. Then the last thing it says, state whether the function is increasing or decreasing. Well, that's easy if you just look at the slope. See, the slope is negative, it's decreasing. But also because the graph from left to right is going downhill. So our answer is decreasing. Okay, so there's our slope. It is decreasing because the slope is negative, and then we have our domain and range. All right, for number 2, let's go ahead and find the domain. I'm not going to draw the box around it. The furthest to the left that we go looks like -1. So -1 less than or equal to x less than or equal to. What's the furthest right we go? Well, we go over 1. Let's see, from the axis, it's 1, 2. So 2. So we'd say that or -1, 2. Okay. For our range, our lowest point is down 1, 2, 3. So -3 less than or equal to y less than or equal to, and then our highest point is starting at 0, 1, 2, 3, 4. So we'd write that as -3, 4 if that was in interval form. Okay, so that's your domain and range. Oops, hard to see there. And then we need to determine the slope. The slope is going to be, well, it looks like up 1, 2, 3, 4, 5, 6, 7 over, what did I do? Over from there, 1, 2, 3. Again, that can't be reduced, so we're going to leave it like that. And then is this function increasing or decreasing? It is increasing because we see the line going uphill from left to right, and we also see the slope is positive. Okay, so that is your practice problems for domain and range. Let's go ahead and move on to the next concept. These are all properties of linear functions, okay? So we have something called x and y-intercepts. Okay. We have something called x and y-intercepts. An x-intercept, so this is back to notes, put it on the left-hand side, and over time I'm not going to keep repeating that, you should just know that. X and y-intercepts. These are the points where the graph crosses your two axes, okay? The x-intercept is where the graph, where the function crosses the x-axis, and that is a point. Where does a line cross through another line? It crosses through at a singular point. So we use a coordinate to identify that point. The x-intercept is where a function crosses the x-axis. And the y-intercept is exactly what it sounds like. The coordinate where the function crosses the y-axis. All right, so those are two, not new terms, but terms we need to review. Let's go ahead and take a look at an example of this. Where is the x-intercept and the y-intercept of this line? Well, looking at this graph, we can see that it crosses these axes. I'm going to go ahead and highlight them with a little circle here. We can see that it crosses one of the axes here, and it crosses the other axis there. Okay, so the question is, which one's which? Well, this, remember, is the y-axis. I might as well go ahead and write that in there. I probably should have done that to start with. This is the y-axis, and this is my x-axis. So what is this point then? This is where it crosses the y-axis, so it's the y-intercept. This is where the function crosses the x-axis, so it's x-intercept. Now somebody might say, well, it's not crossing through it. You're right. It is intersecting it though. It is touching that axis, and that's what we're looking for. So for this example, we would say the x-intercept is this point right here. Well, what is that point? It's over 1, 2, 3, 4, 5, 6. So it'd be 6, 0 as a coordinates because we went to the right. Do I have that right? No, we went to the right 6 and we didn't go up or down, right? And then the y-intercept is this point. Well, what is that coordinate? We just went down 2. So that's exactly 0, -2. So that is my x-intercept and my y-intercept of that graph. Again, when you're identifying them, they should always be written as a coordinate. The x-intercept will always have a 0 for the y value. Okay, that's going to be a big hint for the future. The x-intercept always has a y value for a y value of 0, and the y-intercept always has an x value of 0. Okay, so that is my example for you. Let's go ahead and do some practice problems here, or one big practice problem with 5 different parts. So go ahead and pause the video, see what you come up with, and then come back and watch me do it to see how you did. Okay, for part A, it says find the slope. Well, because we're given a graph, I'm going to go ahead and shrink this screen just a little bit so we can see the end of that graph. Because we were given a graph, we can find the slope just by counting, okay? So we're going to say A, what is the slope? The slope, well, what do we see? The slope, is the graph increasing or decreasing? Well, the graph is going downhill, so it's decreasing, so we'll put a negative out front. That should be obvious. But then we're going to count from left to right. We're going to count, remember we always count from left to right, but we're going to start here, and what's our rise? We go down 1, 2, 3, 4, 5, so that's -5 over, and then we're going to go over 1, 2, 3, 4, 5. So we can see our slope is -5 over 5, and then that reduces, 5 over 5 reduces to 1, so this could be written as -1 over 1 or just -1, okay? And you can see that in the graph also. If I went down 1 over 1, I'm at a point. Down 1 over 1, I'm still on the line. Down 1 over 1, still on the line, and so on. Okay? So for part B, it says create the linear equation in both forms. Well, we have a graph here. So it's really easy to create the slope-intercept form from the graph. We would say, let's see, let me write this as a note. Intercept, if I could write the slope-intercept form, we would say that the y-intercept is what? The y-intercept is 0, 3. We can see that here. We went up 3, okay? And the slope we already figured out is -1. So remember, slope-intercept is y equals mx plus b. So that would be y equals -1x plus 3. And that is our slope-intercept form, slope-intercept, okay? Let me go ahead and zoom out here so I have more room. Okay. For our point-slope form, write that down, point-slope, we need a point, okay? So we're going to say that the point, and you can pick any point you want, but I'm just going to go ahead and use this point maybe. That coordinate is -1, 4. And so typing that into the slope-intercept, or sorry, point-slope form, y minus k equals m times x minus h. Plugging that in, you get y. Remember, you change the sign, so that's a +4, so that's going to say -4, equals the slope, which was -1, times x, and since that's a -1, this will be a +1. So that's one possible answer, okay? If you use a different point, let's say you use this endpoint here, then that answer would be y. Let's see, that coordinate is 4, -1, so that would be y plus 1 equals -1 times x minus 4. That would be another possible answer. If you used another point, because they're all pretty easy to see, you would have gotten a different answer. But the big point is, if you were to convert this to slope-intercept form like we've done in the past, distribute, and then move the constants over, you should still get this as your slope-intercept form. All right, for part C, it says identify the domain and the range. So I'm going to go ahead and put my box around this. I'll use blue for my vertical lines. Move that over just a little bit. And move that one over just a little bit. Oops. Okay, so we can see our box taking shape. And now we need to draw our horizontal lines. And so those would be there and there. So we have our box. So our domain is going to be from -1 less than or equal to x, less than or equal to, it looks like, 4. So from -1 all the way to 4. And then interval notation would be -1, 4. I'm going to just tell you, my personal preference is inequality form. Okay, that doesn't mean I won't ever ask you about interval form. It just means that I prefer it. The range, well, what's the lowest y value? Well, that's -1 less than or equal to y, all the way up to, it looks like 1, 2, 3, 4. Look at that, to 4 again. And then our interval notation will be -1 to 4. So in both cases, it's the same answer, but notice the range is always y values, and the domain is x values. That's just kind of convenient that that worked out the way it did. All right, with that said, oh, we got one more problem here. Two more, I guess. D, it says, is the function increasing or decreasing? Well, we kind of already determined that in part A. Since the slope is negative, and because this graph is going downhill, we would say decreasing. And then part E, it says, what are the x and y-intercepts? So x-intercepts, y-intercepts, write those down. We could put a circle around them if that is beneficial. So we see that it crosses one axis here, and it crosses the other axis there. So what is the x-intercept? The x-intercept is this point, because this is the x-axis. That coordinate is going to be 3, 0. Wrong color here. 3, 0. And then the y-intercept is going to be this point. So what is that coordinate? Well, that is 0, 3. Again, this kind of works out because really the part of the reason is because the slope is -1 here. That's why it worked out the way it was. But the point is, remember the y value in the x-intercept is 0, and the x value in the y-intercept is 0. All right, that wraps up this lesson. Hopefully you got a good grasp of domain and range and x-intercepts, y-intercepts, and the whole bit. This problem is actually a pretty good problem as a summary of linear functions as a whole. If you have any questions, make sure you reach out to me, and I will talk to you later.